So these are 5 arithmetic operators for addition, subtraction, multiplication, division, and modulus. Modulus is also known as remainder. So if we just go back to an integer version of our result example, result of the division, recall that we said that two integers divided yield a result that throws away the remainder of the division. And so the operator modulus right here, that is using a percent sign, or remainder operator, that's its second name, will yield the remainder. So if I run this, you can see that the remainder of the division, 14 by 8, is 6. So 14 divided by 8 is 1 in integer arithmetic, and the remainder is 6. So this is your remainder operator. So in this case, notice also how quickly comments like this, sort of like trivial comments, become obsolete and even misleading. So I change my mind and I am doing something different in my formula, and this comment still says it equals 1. So of course, just be aware that comments like these are okay in some trivial examples, but in serious problem solving, you just have the same responsibility for maintaining comments just as well as the actual computations that you try to implement. So just be aware of it. In most cases, people should expect this to be understood directly as it is. So perhaps comment like this is just totally unnecessary. So just remember that the comments come with the burden of maintaining them and keeping them up to date with the code itself, because if the code begins to change, the comment become incorrect, and they're misleading and create more problems than help. Just be aware of it. There's also this thing, order of precedence, or simply operator precedence rules. Operators can have higher or lower precedence. When we use addition and multiplication, multiplication has a higher precedence as in conventional arithmetics. So this is actually 12 plus 2, which is 14. If this is not the way you want to make your computation, you have no other choice but to parenthesize and group what you want to be computed before outside of these parentheses. So 2 plus 3 is 5, multiplied by 4 yields 20. Pretty simple. If unsure, just search or Google for Java operator precedence, and you'll find a convenient table that will tell you which operators have higher or lower precedence. So just the precedence is built into the operators. You cannot alter it. The operator precedence is always the same, and so one operator can have higher precedence than the other, and that would force the compiler to compute this first before the rest of the expression. Integral expressions simply rely on integral or integer operands. So anything that looks like an integer without a fractional part is commonly known as integral expression. And floating point expressions, of course, involve fractional numbers or real number or floating point numbers. So there is this distinction because we've seen this implication of applying integer and real number arithmetic, and the behavior is different depending on the types of numbers that are involved in these arithmetics. And also, if x and y's are integers but they're mixed in with doubles in the expression, the entire each part of this expression is promoted to a double and will be using floating point arithmetics. And these are the examples of these arithmetics. So this is an interesting thing to take a look at. 6 divided by 4 plus 3.9. So let's copy this and paste into our set of examples right here. And before I do this, I'll just simply get rid of these statements because we already discussed them. And so now I simply want to print the result of this expression. So you see that the outcome of this is 4.9. So this may not be exactly what some people expect. So this presence of a double on somewhere in this expression does not really mean that the entire set of operators here, 6, 4, and 3.9, are all promoted to double. And the reason is because if 6 and 4 are integers, because they do not specify floating point of any sort, they're treated as integers, and the division is an integral division. So if you want to make sure that it works as expected, then you need to change them to the notation of a double by simply using these types of numerical values. So if I run this, of course now it becomes 5.4 because it's just now computes those as real numbers and then adds another double to them. So just be sure that that's how, basically just be careful with these expressions, and remember that if you're really thinking about doing floating point arithmetics and applying that kind of rules, just be sure to be clear about all the parts of your expression and make sure that you keep them the same data type. So in Java, this is a literal integer 6, and this is a literal double floating point 6. There is a difference here. Of course, if this was an integer, but this obviously is a double value, then of course this integer is promoted to a double automatically. But if both of those look like integer, compiler decides that this is an integer expression and will apply the integer arithmetic. Will simply divide 6 by 4, which will be a 1 with the remainder of 2, and the remainder is thrown away, and you are left with the value of 1. And this is why 1 plus 3.9 gives you 4.9, which may not be exactly what you were expecting if thinking about straightforward floating point arithmetics here. So this concludes our presentation on various topics of basic Java programming rules and examples using arithmetic operators.